Semua dah download ya nota lecture notes. Okay, you can refer to that lecture notes. Okay, so module 1 is about the microprocessor based system. So in this module 1, you will learn about the computer. Okay, what are the computer? What are the things that are important in a computer, and then how to differentiate between microprocessor and microcontroller. Okay, so let's go through these slides here. Okay, this one I already covered in the previous slides. Okay, so kita akan tengok apa itu komputer. Okay, so what is computer? Okay, so computer is actually an electronic device, okay, that used for storing and processing data. Okay, so used for data processing and data storage, typically in binary form. Okay, all the data processing and data storage are done in binary number. Okay, so this data processing and data storage will process according to the instruction given to it and in a variable program. So komputer fungsinya adalah untuk memproses data as well as to store a data in a binary form. Okay, so let's look at the 4 basic functions of computer. Okay, instead of using as a data processing and data storage, the computer also use, okay, to do a data movement. Okay, which is you're going to move from one part to another part. Okay, contohlah kamu ada input. Okay, so you're going to move to your CPU. Okay, so that one is another function of computer. Or from that input, you're going to store to your data storage. So that data movement also another function of computer. Okay, and then the last function here is to control lah. Okay, so this control mechanism is used. Okay, it's like a brain lah. Sama ada kamu nak read ataupun nak write. Okay. Okay, so this control mechanism will tell the CPU what to do. Okay, either you're going to process the data, to store the data, or to move the data. Okay, so whenever the word microprocessor is mentioned, okay, setiap kali kalau kamu dengar perkataan microprocessor, so most of us think of desktop computer, ataupun sometimes you think it as a laptop. Okay, setiap kali kamu dengar microprocessor je mesti kamu akan terbayang. Okay, that one is belong to PC. Okay, kenapa PC? Sebabnya dalam PC kita ada microprocessor. Okay, we have a microprocessor, or sometimes we call it as a processor lah. Okay, processor chip such as an Intel, AMD. Okay, so setiap kali kalau kamu dengar processor je kamu tahu, okay, that one is belong to PC ataupun laptop. Okay, maybe at the most your smartphone lah, because the smartphone also have the processor. Okay, which is kamu mungkinlah dengar dia punya ARM processor. Okay, which is for the smartphone we will using a ARM processor lah. Okay, so there are few ARM processor seperti Mali, okay, and then you have the Exynos and all those things. Okay, so in this course, okay, we will look at another type of computing system which is far more common than you ever imagine. Okay, so kita akan tengok lagi apakah type of computer system yang menggunakan microprocessor instead of laptop, PC dengan smartphone. Okay, so computer boleh diklasifikasikan. Okay, so the computer can be classified to 5 types. Okay, so we have the server. Okay, so this server is actually a computer or a computer program that manage access to a centralized resource or a service in a network. Okay, so this service is like a pelayan lah. Okay, so this one used to in order for us to connect to internet. Okay, so this server is big and it is a very expensive lah, because you're going to because it is this server must be reliable and faster, okay, in order to work 24/7. Okay, kalau contohlah kamu punya server down, so what happens? So user akan marah nanti. Okay, every time you going to log into contohlah kalau kamu nak pergi Shopee, okay, so tiba-tiba the Shopee is shut down. Okay, dan kamu marahlah sebab kamu nak beli barang. Okay, so that is one is a server. Okay, then we have a desktop. Okay, which is a computer on your desk. Okay, so this computer on your desk sekarang ni selalu digunakan di pejabat-pejabat lah. So dulu, okay, selalu digunakan di rumah. But nowadays, kamu akan start jarang dah nampak desktop dekat rumah. Okay, selalu kita akan nampak di pejabat ataupun di makmal komputer. Okay, then we have a laptop, okay, which is computer that you can carry in your bag. And then we have the sebelum ni kita ada PDA, okay, which is a personal digital assistant. And then after that, okay, it involved to become a tabs, and nowadays we use it a smartphone. Okay, so this one here is a computer that you carry in your pocket because it is small enough kita boleh carry dalam kita punya pocket. And the last one here, okay, the last type of the computer is called as a embedded system. Okay, in which this embedded system is a computer that doesn't look like computer. Okay, dia adalah komputer tapi dia tak kelihatan macam komputer. Contohnya, siapa nak bagi contoh embedded system? What is the example of embedded system? Anyone? Contoh paling simple. What is the example of embedded system?
ECU kereta.
Tak dengar Idris. Apa dia?
ECU kereta.
Okay, correct. Calculator. Okay, so calculator is embedded system lah. Okay, di mana dalam calculator itu ada CPU, okay, your processor, and then you have an input output. Okay, input is your the keypad yang kamu nak tekan, and then output ialah kamu dia punya display untuk menunjukkan hasil calculation, and satu lagi dia ada memory di dalamnya. Okay, so that one is a embedded system. Okay, so actually embedded system is a computer system with a dedicated function within a larger mechanical or electrical system, often with a real-time computing constraint. Okay, so this microprocessor-based system built to control a certain function. Okay, so setiap kali kamu jumpa embedded system, dia hanya akan boleh buat a certain function. Dia tak boleh buat function yang lain. Contohlah kalau kamu beli calculator, that calculator only can do calculation. Okay, that is the basic punya calculator lah. Kamu boleh buat tambah, tolak, bahagi and dapatkan percentage. But if you buy another calculator called a scientific calculator, okay, you can do the derivation, kamu boleh buat pengkambiran, okay, you can convert, okay, you can use that calculator to convert from binary to decimal numbers, and you can convert from hexadecimal to octal number, and then you can do all kamu akan boleh buat macam-macam function compared to the basic calculator. Okay, because embedded system is a microprocessor-based system that is built to control a certain function. Okay, depending on the embedded system yang kamu beli itulah. Okay, sama ada dia boleh buat a few function ataupun banyak function. Okay, so this one give example of embedded system. Okay, so yang ni kita tak perlu buat. Okay, so contoh paling simple saya nak bagi kamu. Okay, dalam kereta. Okay, dalam kereta there are a lot of embedded system. Dalam satu kereta je ada banyak embedded system. Okay, you have a GPS receiver. Okay, that one is a embedded system. Di mana GPS receiver used to pinpoint your location. Okay, nak tahu kamu punya. Okay, kamu nak tunjukkan jalan, okay, destination yang kamu nak pergi. And then you have a radio. Radio also one of the embedded system. Actually, especially yang digital punya radio lah. Okay, and then you have the okay, so kamu ada contohlah kita ambil kat sini. Okay, untuk security, okay, for the security we have the remote keyless entry. Okay, so this is one of the embedded system. Okay, kamu punya remote is one of the embedded system, and then we have the immobilizer, also one of the embedded system. Okay, for the safety, okay, the airbags, okay, to deploy the airbags, okay, that one belong to one embedded system, okay, which is the airbag will be deployed bila kamu ada collision. Okay, and then direct TPMS, okay, TPMS stand for tire pressure monitoring system. Okay, bila kamu punya tire pressure getting low, then dia akan give an indicator mengatakan tire pressure kamu kurangan angin. So that is one of the embedded system. So inside of this one car, actually there are a lot of embedded system with a different function and purpose. Okay, so sekarang kita nak cuba bezakan, okay, antara general purpose computing ataupun general purpose computer dengan embedded system. Okay, kita nak classify antara between these two. Satu komputer, satu embedded system. Apakah yang membezakan mereka? Okay, so for the computer, okay, is intended to run a fully generous set of application. Okay, kamu boleh guna banyak application di dalam sesebuah komputer. But for the embedded system, okay, it only run a few application often known at the design time. Okay, contohlah. Okay, for the general purpose computer. Okay, kita ambil contoh kamu punya laptop. Okay, so laptop, let's say lah. Okay, kalau kamu dekat laptop, kamu boleh tengok video, betul tak? Okay, so in order to watch a video, okay, kamu kena install movie player. Okay, so window player such as VLC, media player, so kamu kena install, and then barulah kamu boleh tengok video. But for the embedded system, okay, kamu tak boleh tambah what we call here. Contohlah kalau okay, it's only run a few applications. Contohlah macam yang saya cakap tadi, a normal calculator. So normal calculator only can run, can do normal arithmetic such as tambah, tolak, bahagi dan darab. Okay, but if you're going to do to get to do a binary conversion, okay, nak buat integration, to get the sin, tangent, okay, you cannot use the normal calculator. You kena guna scientific calculators because it's run a few application only known at the design time. Okay, and then the general purpose computer, okay, this one is end user programmable. Maksudnya kamu boleh reprogram, okay, so that dia boleh run another application. Contohlah macam tadi, okay, kamu nak untuk komputer, nak tengok video, kamu kena install a software atau install a program such as a movie media player, okay, ataupun kamu ada VLC, okay, barulah dia boleh run video, okay, tengok video. Okay, kalau kamu nak dengar listening to song, okay, you can install Winamp, iTunes, okay, barulah kamu boleh dengar listening to song. Okay, if you're going to play games, of course dekat komputer kita boleh play games. Macam mana kita nak play games? Okay, kita boleh install game yang kita nak main. Okay, so that is for the computer lah. Okay, which is it is end user programmable. But untuk embedded system, not end user programmable. programmable. Okay, kamu tak boleh install apa-apa. Okay, contoh calculator tadi. Okay, so once you buy that calculator, so kamu tak boleh tambah another features to that calculator. Okay, so that is belong to embedded system. Sama juga lah kalau kamu beli apa ni digital watch. Okay, kawan kamu beli digital watch yang boleh tunjukkan masa saja. Okay, and then suddenly Ali beli digital watch boleh menunjukkan masa and then dapatkan ECG monitoring. Okay, so yang Abu ni tadi, since dia beli yang digital watch yang tunjukkan masa je, dia tak boleh nak buat ECG monitoring. Okay, so dia tak boleh, it is not end user programmable. Okay, and then for the computer, faster is always better lah. Okay, of course lah, bila kamu ada komputer yang super powerful, okay, which is fastest, okay, and okay, maksudnya kamu ada higher RAM, processor yang tinggi, so baguslah. Okay, compared to embedded system, okay, it's only operate in the fixed runtime constraint. Okay, additional performance may not be useful or valuable. Kenapa? Sebab this one here, kamu hanya nak run a few applications, so no need to have a very powerful embedded system. But for the general purpose computer, of course lah, sebab kamu nak run many applications, so you need to have very powerful computer. Okay, so how to differentiate between one computer to another computer? Okay, in terms of the speed. Okay, contohlah laptop A, okay, the processor is 4 GHz. Okay, laptop B, the processor is 4 GHz, but it's a quadruple microprocessor. Okay, so the speed is different from computer A and computer B. Walaupun dia punya speed apa ni, what we call here, the processor speed is same 4 GHz, tapi the apa ni, laptop A cuma single core, but the laptop B is okay, ada 8 cores for example. So dia punya speed dah berbeza-beza. Okay, and then software compatibility. Okay, so this is one of the how to differentiate between computer, which is kalau kamu ada computer A is run on the iOS, computer B run on the Windows. Okay, so dia punya apa ni, software compatibility dah berbeza lah antara computer A dengan computer B. Ada software boleh run dekat iOS and that software cannot run to the Windows, and ada software boleh run to Windows but cannot run to the iOS. Okay, and then cost, okay, of course lah, cost is the main factor lah. Okay, ada komputer yang harganya murah, ada komputer yang harga tinggi. Okay, but the murah computer is the spec is lower lah compared to the highest, okay, the expensive computer. Okay, so untuk embedded system, macam mana kita nak bezakan antara one embedded system to another embedded system? Okay, first kita tengok dia punya power consumption. Okay, contohlah kamu ada calculator, normal calculator lah yang kita nak buat, tambah tolak bahagi darab. Okay, ada calculator yang gunakan 2 bateri 1.5 volt. Ada yang guna 1 bateri 1.5 volt. Ada yang guna solar power. Okay, so that one is a power in terms of power consumption. And cost, this calculator A harganya RM5. Calculator B harganya RM10. Kenapa berbeza? Sebab mungkin dia punya power. Okay, yang calculator B, dia ada solar power tadi. Okay, so that's why the harga quite expensive compared to calculator A. And then the size of that calculator mungkinlah lagi besar. Okay, senang kamu nak tekan press dia punya keyboard. Okay, and then speed. Okay, untuk speed tak berapa ni sangat lah. Okay, as long as it's predictable, can run that few applications is more than enough. Okay, so speed tak memainkan peranan yang penting untuk embedded system. Okay, any question? Ada soalan tak sampai sini? Okay, so kalau tak ada soalan, so kita akan go to the next slide. Okay, so to design a microprocessor system, okay, so we need to know the three things here. Okay, fundamental, programming, and hardware design. So let's look at the fundamental parts here. Okay, so untuk fundamental kita akan tengok what is inside the computer and what is inside a processor. Okay, kita nak tengok apakah komponen-komponen yang ada dalam komputer and processor. So in internal organization of computer, okay, so every computer can be divided into three main parts. Okay, setiap komputer mesti ada tiga benda penting ni. One is a CPU, satu lagi memory, and satu lagi input-output device. Okay, kalau tak ada salah satu ni, tak boleh jadi computer system. Okay, it must have the CPU, which is a central processing unit, and then the second one kena ada memory, okay, which is this is to store data lah. Okay, sama ada kamu use a RAM ataupun ROM. Okay, and then the last one is your input-output peripherals ataupun input-output devices. Okay, contohnya seperti keyboard, mouse, and sensor for inputs, and output is LCD, printers, monitor, LED, bulbs, and etc. Okay, yang boleh menunjukkan outputs. Okay, so in a computer, this is the three main things lah: CPU, memory, and input-output. Okay, in the embedded system pun sama juga, kena ada CPU, memory, and input-output, but it has the structure a bit smaller lah compared to the computer. Okay, so let's look more detail on this CPU, memory, and input-output. Okay, so for the CPU, okay, this CPU used to control the operation of the computer and perform its data processing function. Okay, often simply referred to a processor. Okay, so CPU ni dia punya brain lah. Okay, kita punya brain of our computer. Okay, di mana dia gunakan untuk control operation, untuk buat data processing, untuk buat logical function, and etc. Okay, so the CPU is used to execute information stored in memory. Okay, setiap information that stored in memory will be executed by CPU. Okay, so execute information ni kita panggil dia sebagai data processing lah. Okay, so the I/O device is used as a communication medium with a CPU. Okay, in order to do the data processing, okay, we need to sambungkan kepada input, output, and memory. So macam mana kita nak buat communication between CPU, input, output, and memory? By using this strip of wires called a buses. So this is a communication way lah untuk CPU, okay, communicate with a memory, and CPU to communicate with input output in order to do data processing. Okay, by using this okay wire called a buses. Okay, kita ada tiga jenis bus: address bus, data bus, and control bus. Okay, in the next few slides kita akan tengok more detail on these buses here. Okay, so the CPU is made of three main unit. Okay, dalam CPU ada tiga benda penting lagi. Okay, so inside of the CPU we have the three main things. Okay, so this is your CPU. Okay, so if you look deeper to that CPU, you have a ALU. Okay, so you have a ALU. Okay, so this ALU is arithmetic logic unit, which is used to perform all arithmetic operation. Okay, so all the arithmetic operations such as tambah, tolak, bagi, darab, and logical function akan diproses dekat ALU. Okay, so tambah, tolak, bahagi, darab akan dibuat di dalam ni lah. Okay, logical function seperti OR and exclusive OR also akan dibuat di dalam ini. Okay, and then we have a control unit. So unit kawalan. Okay, so this control unit to control and synchronize the overall operation of the microprocessor and microcontroller system. Okay, so this is the controller lah. Okay, sama ada kita nak control, kita nak ambil data tu daripada memory ataupun kita nak ambil data tu daripada input. Okay, so that one will be controlled by a control unit. And then we have a daftar kat sini, which is known as a register. Okay, so a register is a set of internal storage location within CPU. Okay, so the register ni sama dengan similar to your memory lah. But this is only a temporary storage data. Okay, di mana kamu nak simpan data temporarily. Okay, there are two type of CPU. Okay, kita ada dua jenis CPU. Okay, one is a microprocessor. The other one is microcontroller. Okay, later in the next few slide kita akan tengok what are the difference between micro P dengan micro C. Okay, so that one is a CPU. Okay, so sekarang kita nak tengok pada kita punya memory. Okay, to make a 1-bit computer system, we need to have a CPU, memory dengan input output. So now we're going to see what the memory is. Okay, so the memory store the memory information needed by CPU. Okay, so all the data you're going to process will be stored inside the CPU. Inside this memory. Okay, before CPU can process that. Okay, there are two types of memory. Okay, I assume that all of you already learn about this thing here. Okay, in the digital electronics, kita ada dua jenis memory, satu ROM, satu RAM. Okay, ROM is a non-volatile memory, while RAM is a volatile memory. Okay, so this one you can okay, go through here. Okay, ataupun kamu boleh refer to your digital electronics for this. Okay, next we have a computer buses. Okay, so this computer this buses is used to communicate between CPU with your memory tadi and CPU with your input output. So buses ni ada tiga jenis bus. Okay, kalau kamu tengok, kamu ada tiga jenis bus: address bus, data bus, and control bus. So now we're going to see what these buses do. Okay, so let's look at the control bus yang bawah ni dulu. Okay, kalau kamu tengok bawah ni, this control bus ya, kamu tengok dia punya arrow, okay, masuk ke CPU and keluar dari CPU. So we call it as a bidirectional bus lah, sebab kamu boleh dia punya data can come in to your CPU or go out from the CPU. Okay, so this control bus, okay, used to provide a read or write signal to the device, indicate if the CPU is asking for information or sending information. Okay, so yang ni sebagai controller lah, sama ada dia akan terima signal read ataupun write. Okay, kalau read, okay, kalau CPU dapat terima signal read, CPU tu tahu yang dia nak baca data daripada luar masuk ke dalam CPU. Okay, if you put a write signal, what happen here? The CPU know that you're going to what we call here, to send out the data daripada CPU, okay, to your memory ataupun to your input output. Okay, read, kita nak baca data daripada input output atau memory masuk ke dalam CPU, and write, nak send out the data from CPU to input output or memory. So this is the control bus. Okay, what the control bus do. And then we have the data bus. Okay, again data bus, kalau kamu tengok, this is a data bus. Okay, so sama juga dengan control bus, dia ada anak panahnya masuk dengan keluar. So this is a bidirectional as well lah. Okay, used to carry information in and out from CPU. Maksudnya, okay, kalau kita read, okay, kalau kita terima, kalau CPU terima read signal from control bus, so the CPU know that, okay, kita nak baca data, okay, nak ambil data daripada input output ataupun memory masuk ke dalam CPU. Macam mana kita nak masukkan that data? Dia akan menggunakan data bus. untuk move that data from input output or memory to the CPU. Okay, if the control bus saying that, okay, now write the data. Okay, so the CPU knows that we're going to send out the data from CPU to input output out of a memory. Macam mana nak buat? Okay, by using the data bus to send out that data. Okay, so the more data buses available, the better the CPU, but more expensive. Okay, so the size of this data bus will determine the processor speed. Okay, but if you have more data bus, maksudnya kamu punya CPU speed akan increase, but the value will be expensive. Okay, pernah dengar tak? Okay, computer with a 64-bit computer, 32-bit computer, 16-bit computer, and 8-bit computer. Pernah dengar tak? Okay, sekarang kita punya komputer pada tahun 2021 ni adalah 64 bit. Okay, maksudnya 64 bit ni is the size of the data bus. Okay, so the processing power of computer is related to the size of its data bus. Contohnya lah, 8-bit bus can send 1 byte a time, while 60-bit bus can send 2 byte at a time, which is twice as fast. Contoh lah, saya bagi contoh. Kamu ada computer is a 64-bit computer. Computer B is 32-bit computer. Okay, C is 16-bit computer, and 8 is and D is 8-bit computer. Okay, kamu ada 64-bit data. Okay, kamu nak transfer. Okay, kamu ada 16-bit data untuk komputer A. Berapa cycle yang diperlukan untuk menghantar 16-bit data? Okay, you going to have 1 cycle je lah. Okay, sebab size yang kat sini 16 bit. Okay, so kalau kamu ada 16 bit data, maksudnya cukup nak hantar menggunakan this 16 bit data bus. Okay, ngam-ngam. Okay, kalau kamu ada 16 bit data, tapi kamu guna 32 bit komputer. So macam mana nak buat? Dia punya data bus hanya 32 bit. So what you going to do? You need to divide, you need to kecilkan lah. Kamu punya data ni, okay, from 64 bit, kamu kena kecilkan dia kepada 32 tambah 32. So how many cycle you going to send out in order to, how many cycle that you require in order to send out the 64-bit data? 2 cycles. Di mana first kamu kena hantar the first 32-bit and then followed by the second 32-bit. Okay, what about the computer C? Okay, this computer C only 16-bit size. Okay, kamu nak hantar 16 bit data. So macam mana nak buat? Okay, so kamu kena buat 16 tambah, okay, kecilkanlah dia punya data yang 64 ni, kamu kena kecilkan dia kepada 16 bit chunk. Okay, 16 tambah 16 tambah 16. So how many cycles? 1. Okay, untuk hantar dulu 16 bit, and then hantar another 16 bit, dah 32 bit, hantar lagi 16, hantar lagi another 16, so kamu dapat 64 bit. So you require 4 cycles. Okay, so yang ni lagi slow lah compared to this one. This one kita hanya perlukan 1 cycle je. 32 bit komputer, 2 cycle. Tapi kalau kamu pakai 16 bit komputer, dah kena pakai 4 cycle. 8 bit, macam mana dengan 8 bit? Okay, kamu kena kecilkan dia kepada 8 tambah 8 tambah 8 tambah 8. Berapa kali 8 ni? Kamu kena 8 kali. Okay, so 8 cycle required in order to move 64-bit data by using 8-bit computer. Okay. Okay, so the size, the data bus is very important lah. Okay, in order to determine the speed of your CPU. And last but not least, the address bus. Okay, for the address bus, it is a unidirectional bus. Kenapa unidirectional bus? Okay, sebab dia punya anak panah dia satu je, keluar je. dia tak akan masuk ke dalam CPU. Okay, so used to identify the device and memory connected to CPU. Okay, since this is an address bus, digunakan untuk kamu identify lah device yang nak connect kepada CPU, okay, which is your I/O and your memory. Okay, for a device to be recognized by a CPU, it must be assigned by an unique address. Contoh paling senang address bus ni, macam mana the address bus function is, contoh kamu nak hantar surat ataupun postcode kepada kawan kamu. Okay, first what you need to do in order to send out the postcode or surat. So you need to know the address, the house address of your friends. Okay, kamu kena tahu dia punya alamat. Okay, kalau kamu tak tahu dia punya alamat, so kamu tak boleh hantar surat tu ataupun postcode tu kepada kawan kamu. So that is the address bus lah. Okay, di mana dia membawa alamat. Ataupun another example. Okay, you're going to send a message to your friend. Okay, macam mana kamu nak send a message to your friend? Macam mana nak send SMS? So you need to know the phone number of your friends. Okay, kalau kamu tak tahu dia punya phone number, macam mana kita nak hantar SMS? Okay, so that is how the address bus works, di mana dia used to identify the device and memory connected to your CPU. Okay, so the more address bus available, the larger the number of devices can be addresses. Okay, so address bus ni, kalau kamu ada banyak address bus, maksudnya kamu boleh sambung banyak device kepada kamu punya CPU. Okay, so that is the meaning by address bus. Okay, any question tak? Ada soalan? Okay, kalau tak ada soalan, okay, I think we take 5-minute breaks, and then after that we continue with this one here. Alright, so now we're going to see what are the difference between microprocessor and microcontroller. Sebab tadi kita tengok CPU, okay, the central processing unit have two types. Okay, satu is a microprocessor, satu lagi is microcontroller. So now we're going to see the difference between both of them. Okay, so microprocessor is a single integrated circuit, okay, a single IC. Okay, dalam kalau kamu beli satu IC ni, dia hanya ada microprocessor saja that accept and execute coded instruction, machine code or machine language for the purpose of manipulating data and controlling the associated circuitry such as a RAM, ROM, input-output in a digital signal. Okay, and then if you going to buy the microprocessor, so bila kamu beli je microprocessor, what happen is kamu hanya dapat satu chip ni, di mana dalam chip ni hanya ada satu, okay, ada hanya microprocessor saja. Okay, in which microprocessor by itself is a completely useless. Kenapa useless? Sebabnya in a computer system, okay, as I mentioned earlier, to make one complete computer system, you need to have a CPU, memory, dan input-output. Okay, sekarang ni kita hanya ada CPU saja. Kita hanya ada microprocessor saja. Okay, tak ada ROM, tak ada RAM, tak ada memory, tak ada input-output. Okay, so the hijau here is the memory, and while this orange here, this one here, this color here is belong to your I/O. Okay, so this is a I/O and this is a memory. Okay, bila kamu beli je microprocessor, kamu hanya ada CPU saja. Benda-benda lain ni, memory dengan I/O tak ada. So, microprocessor by itself is completely useless. Tak berguna. Okay, so macam mana nak make this microprocessor work? You need to have an external peripherals lah to interact with outside world. Means that you need to buy a memory chip, and then you need to buy the I/O peripheral chip, connect them to the microprocessor, so that kamu akan dapat one complete computer system. Okay, that is a microprocessor. Okay, only consists of CPU sahaja, tak ada memory, tak ada I/O. Macam mana nak jadikan one complete system? Kamu kena beli another chip, okay, which is a memory chip as well the I/O peripheral chip, and sambungkan dia kepada kamu punya microprocessor tadi. Okay, in the meantime, okay, for the microcontroller, okay, sama juga, microcontroller is also a single integrated circuit. Okay, so this is a micro C. Kamu kalau pergi kedai, kata nak beli Atmega this microcontroller chip, so kamu akan dapat benda macam ni. Okay, that accept and execute code instruction for the purpose of manipulating data and controlling the digital system similar to micro P. Bendanya sama. Okay, apa yang beza? Okay, the difference between micro P and micro C is that the microcontroller contain RAM, ROM, and I/O in that single IC package. Okay, maksudnya bila kamu beli je IC ni, kamu dah ada CPU, kamu dah ada ROM dengan RAM ataupun RAM, dan kamu dah ada I/O peripherals. Maksudnya satu chip ni dah jadi one complete computer system. Okay, so those allow miniaturization of a single application because the required associated circuit is contained within the IC of microcontroller. Okay, so kalau kamu tengok ini, so this is a microcontroller. Okay, so this is microcontroller. So dalam microcontroller dah ada CPU, okay, dah ada memory, and dah ada I/O peripherals. Okay, so that is the difference between microcontroller and microprocessor. So another difference between microprocessor and microcontroller is, okay, so this one is a chip that contain only the processor. Okay, microprocessor hanya ada CPU saja, but microcontroller dah ada CPU, ROM dengan RAM. Okay, so for the microprocessor need other chip to make a working system. Means that you need to buy another chip lah, which is you need to buy a memory chip. Okay, which is consists of ROM or RAM chips, and then as well as the I/O peripheral chip in order to make one working system. Okay, but this one ya, no need lah, tak perlu dah. Sebabnya kamu dah ada CPU, kamu dah ada memory, dah ada input output dalam that chip. Okay, that IC. Okay, microprocessor more flexible, and this one less flexibility. Okay, kenapa yang ni more flexible and this one less flexibility? Okay, contoh. Okay, contoh kamu ada satu projek. Okay, you have one project. Okay, you're going to design a system. Okay, that system require you to have 8 sensors. Okay, kena ada 8 sensors. Okay, kamu kena sambung sistem kamu kepada 8 sensors. So kamu belilah micro P. Okay, so this is micro P. Okay, and then you kena beli IC untuk memory. And then you will beli IC I/O IC that consist of 8 input output port. Okay, kenapa kita nak accommodate these 8 sensors? Okay, this is for the micro P. Micro P. Okay, so student A dia pakai micro P. While student B, okay, dia tak nak pakai micro P. Okay, he going to buy a microcontroller. So dia beli satu microcontroller. Okay, so this microcontroller dah ada memory, dah ada CPU, memory dengan I/O. Okay, so the I/O yang support by this chip yang dia beli adalah 8. Kenapa 8? Sebabnya dia nak pakai 8 sensor. Okay, so sekarang ni, now, okay, so now the lecturer, okay, kata, okay, now we going to expand our system. Okay, instead of using 8 sensor, kita nak tambah lagi another 8 sensor, which is consist of total number of sensor yang kamu kena guna ialah 16 sensor. So what happened to the student A? Okay, student A, apa yang dia perlu buat ialah dia hanya perlu tambah lagi I/O. Okay, dia beli lagi I/O peripheral chips, okay, which is can support to another 8 sensors input output. Okay, so kamu ada 8 tambah 8 dah boleh buat 16 input output ports. But for the student B, since chip yang dia beli tadi hanya support 8 input output, which is can connect to 8 sensors. So what are he going to do? Dia nak buat 16, dah tak cukup. So apa yang kena buat? Dia kena beli lagi satu chip. Beli chip yang baru. Okay. Microcontroller chip yang ada CPU, ada memory. Okay, now the sensors yang dia input output yang support sekarang ni dia beli 16 input output ports. Okay, which is to accommodate this 16 sensor. Okay, so this one dah wasting money lah. Okay, compared to this one. Okay, that why we call it more flexible. Kenapa flexible? Yang ni kalau kita nak expand kita punya sistem, kita hanya tambah je apa yang tak cukup. But for this one, less flexibility. Kenapa less flexible? Because in order to dia tak boleh expand. Okay, so whatever you buy, itu je kamu boleh guna. If you going to expand your what we call it, your in order to expand the features, okay, the system, okay, you require to buy another microcontroller. Okay, of course lah, untuk sensors, okay, kita boleh buat a few tricks lah. Okay, kita boleh pakai buffer untuk increase the number of input output. Tapi kalau nak in term of speed, dah tak boleh lah. Okay, because the speed is fixed. Okay, untuk sensor mungkin kita boleh tambah buffer ke apa ke. Okay, so tak perlu beli yang ni. Tapi contohlah kalau speed dah tak boleh. So yang ni, contoh yang ni kamu beli 8 MHz speed. Now you going to increase that 8 MHz jadi 16 MHz. So what you going to do? So you need to buy a new chip lah with a 1 MHz processor. Tapi kalau yang ni, mula-mula dia beli 8 MHz chip. Okay, processor. So what happen now? Nak increase kepada 16 MHz processor. So dia tukar je lah ni. Tukar je microprocessor punya chip. Jadi 16, yang lain-lain boleh guna. So that is a more flexible and less flexibility. Okay, and then last here can have a very few I/O or many I/O devices using the same microprocessor chip. Okay, so this one less component count in system. Okay, kenapa dia? Okay, because okay the controller that you use is depending on the masa kamu beli itulah. Okay, and is less powerful compared to microprocessor. Okay, any question up until here? Ada soalan tak? So we finish our fundamental part, which is the what inside the computer and what inside the processor. Ada soalan? Yeah? Tak ada ya? Okay, tak. Kalau tak ada, now we're going to the next slide. Okay, which is now we're going to focus on the programming part. Okay, so in the programming part, okay, you will learn about what happens in the processor. Okay, of course lah, kita tak buat programming lagi, tapi kita kena tengok apa yang diperlukan in order to make a program. Okay, to do a programming. Okay, so kamu kena tengok in the next few slides, you will learn about what happens in the processor when it's running a program. Okay, what you need to do in order to write a program, how to create a program, how to run a program, how to do debugging. Okay, so let's look at the overall of the programming part. Okay, so first when we're going to see the software. Okay, so the software, okay, or computer software is a computer program. Okay, concept of computer program yang digunakan untuk do a certain function. Okay, so to do a programming, you need a computer software. So dalam kelas ni, kita akan gunakan AVR Studio sebagai kita punya programming software. Okay, for example, kalau kamu gunakan Arduino, okay, you're going to use the Arduino IDEs, okay, in order to do the programming. Okay, let's say if you're going to use the do a Java programming, so you need to use the Eclipse or JBuilder, okay, in order to do that Java programming. Okay, untuk C programming, contohnya kita boleh pakai computer software seperti Turbo C++, Oracle, Visual C++. Okay, and then kalau kamu nak guna HTML programming, okay, kamu kena pakai MyPHP lah ataupun Adobe Dreamweaver. So that's one is a computer software. Okay, which is a programming that you need to a program that you need to do a programming. Okay, and then a program is a sequence of instruction that perform a task. Okay, so inside of this is a program. Okay, this program here is written in the assembly language. Okay, so this program used to do many tasks. Okay, dalam satu program you can do many tasks according to the program that you will write. Okay, yang akan kamu tulis. Okay, then for the instruction, okay, instruction is the simplest operation performed by the processor. Okay, contoh instruction, okay, this is an instruction. Okay, this is one line instruction and this is the second line instruction. Kalau kita pergi semula kepada kita punya program, okay, this is one program. Okay, inside of this one program you have many instruction. Okay, so this is the first instruction, second instruction, third, fourth, and you have many instruction inside of one program. Okay, so now the persoalan is how to execute this program here. Okay, how to execute this program? Okay, to execute a program yang kamu tulis ni, so what you need going to do is you need to do instruction by instruction. Okay, we need to execute instruction by instruction. In this case, line by line lah. Okay, then start daripada atas. Okay, starting from the top here. Okay, sampai bawah ni. Okay, you're going to execute lines by lines. Okay, so this execution known as a fetch and instruction. Okay, in which we're going to fetch an instruction from a memory, decode the instruction, execute the instruction, and repeat. Okay, so kita panggil this sebagai fetch and execution. Okay, mula-mula kamu fetch dulu, and then after that you do the execute. Okay, program yang kamu akan buat. Okay, so now we're going to see the programming language available. Okay, so kalau kamu tengok pyramid ni, okay, so this is a pyramid here. Okay, you can see the bottom here is your hardware. Okay, hardware duduk paling bawah sekali, and then followed by machine language. Okay, so this machine language here will communicate directly to your hardware. Dia akan communicate directly to the hardware. So machine language is actually the lowest level programming language. Okay, programming language yang paling bawah sekali. Okay, machine language. Di mana it is a set of instructions that executed directly by CPU. Okay, while easily understood by computer, machine language are impossible for human to use because they consist entirely of numbers. Okay, di mana machine language ni adalah dalam bentuk binary numbers. So kita takkan faham. Only hardware ataupun CPU saja yang faham. Okay, contoh kat sini. Okay, so this column here, okay, yang ada red box ni, okay, this is the machine language. Di mana kalau kamu tengok ni, it represented by hexadecimal number. Okay, sometimes it represented by binary number and sometimes it can be represented by hexadecimal number. Of course lah, kalau binary ni panjang ni nak tulis ni. Okay, so to make it simple, it use the hexadecimal number. Okay, so dekat kolom yang ni, okay, kalau kamu tengok kolom yang ni, this is the assembly language. Okay, so assembly language is a second lower of the second lower level programming language. Okay, before the machine language, and on top of the here is the high level language. Okay, seperti C programming, Fortran, Java, Visual Basic, PHP, HTML, and etc. Okay, so kalau kamu tengok dekat sini, untuk assembly language, kita masih boleh faham lagi setiap instruction yang ditulis. Compared to machine language, memang kamu tak tahu apa nombor ni represent. Okay, macam assembly, kalau push ni, okay, kamu tahu, okay, for the push, kita nak put a data to our stack pointer. Kalau MOV, okay, you can guess lah. MOV is move a data from one register to another register. Kalau AND, okay, you know that AND sound familiar. Okay, this one is used to do a logical AND. Okay, SUB. SUB is what is sub? Okay, subtract is SUB is actually from the subtract, means kamu nak buat operasi tolak. Okay, so assembly language kita masih lagi faham apa yang diguna by referring to this mnemonics. Okay, yang ni kita panggil, yang tepi ni kita panggil mnemonics. Okay, by referring to this mnemonics, kita tahu apa yang program ni nak buat. Of course lah, kalau C programming lagilah senang, mudah, kita nak tahu kenapa dia hanya pakai simbol untuk tambah, pakai tambah, operasi bahagi, pakai dia slash, tolak, darab, star. Okay, so dia ada a few syntax lah yang kita kena tengok. Okay, so assembly language, okay, so this is a lower level programming language for a computer, just before the machine language. So assembly language use a mnemonic representation. Okay, dia akan pakai mnemonic representation to represent each low level machine operation. Contohlah, kalau kamu nak buat multiply, nak buat darab, dia punya mnemonic representation is MUL. Kalau kamu nak buat addition, mnemonic is ADD. Subtraction, SUB. Kalau kamu nak move data, MOV. Kalau kamu nak load data, kamu akan pakai LD. Okay, so dia pakai mnemonics. Okay, assembly can be two type. Okay, untuk convert daripada assembly kepada machine language, kita kena pakai assembler. Di mana disassembler ada dua jenis, satu cross assembler, satu native assembler. Okay, so what is a cross assembler and what is a native assembler? So cross assembler run on one computer and generate machine instruction that will be executed by another computer. Maksudnya kat sini, okay, kamu convert assembly language kepada machine code dekat komputer A, tapi kamu run that machine code dekat komputer B. So that one we call it as a cross assembler. Okay. While native assembler, okay, kamu generate a machine code, okay, kamu run this assembly, okay, tukarkan dia kepada machine code dekat komputer A, and kamu boleh run this machine code at the same computer. So we call it as a native assembler. Okay, so the drawback of assembly program are, okay, it's dependent on the hardware organization. Okay, so that's why we need to know the hardware architecture. Kita kena tahu dia punya hardware architecture in order to do a assembly language. Sebab kita nak tahu berapa banyak bilangan register, what is the number of the input output, dekat manakah dia punya input output pin. Okay, you need to know all those things before you can write down the programming. Okay, and sometimes it is difficult to understand long program. Okay, kalau program yang short program, senanglah kita nak faham. But if the long program, okay, very difficult to understand. And last is low programmer productivity. Okay, that is all for the assembly language. Okay, now we're going to see the fetch and execute. Macam yang saya kata tadi, macam mana how the computer works by using the fetch and execute. Kamu ada program, macam mana kita nak execute that program by execute lines by line. Kita akan buat ambil satu instruction by using this fetch and execute cycle. Okay, so the processor execute instruction one by one according to the sequence found in a memory. Okay, so processor akan ambil lah, dia akan run execute instruction line by line depending on the instruction that is found in the memory. Everything is controlled by the control unit. Okay, so control unit inside of the CPU will control the way this instruction execution. To execute an instruction, the processor must fetch it from memory. So kamu kena ambil dulu instruction one by one, baru kamu boleh execute. Okay, so the complete step of the processor takes to execute one instruction is known as an instruction cycle ataupun fetch execute cycle. Okay, so untuk macam ni lah. Okay, kamu ada 3 instruction, so kamu akan ada 3 fetch and execute cycle in order to execute these 3 instruction. Okay, so contoh this is one program. Okay, kamu ada one program here. So what happen here? So CPU akan fetch line by line. Dia akan fetch and execute line by line. Okay, and later I will show you how the fetch and execute works. Macam mana dia berfungsi. Okay, so this is the instruction cycle detail. Okay, how the fetch and execute works. Okay, first on the program start, what happen is you're going to load the program counter with the address of first instruction. Okay, so what happen is the CPU akan ambil address of the first instruction and letak pada program counter. Okay, and then barulah kita masuk kepada fetch phase. Okay, fasa fetching. Okay, di mana read the instruction and put it into instruction register. Okay, so tadi kita dah ada alamat. So daripada sini CPU pergi to this address. Okay, which is consists of the instruction. Okay, contohlah this instruction here. Okay, so ambil instruction ini dan letak dalam instruction register. Okay, and then this instruction register will be decoded. Okay, so the instruction inside the instruction register will be decoded by control unit, and the program counter yang PC ini tadi akan increment by 1, which is dia akan ambil the next address of the next instruction. Okay, and then after that, bila dah habis fasa fetch, barulah dia buat execute phase, fasa execution, di mana based on this instruction, dia akan execute lah based on the instruction, find the data required by the instruction, perform the required operations, store the results. Okay, dia akan buat 3 step ni, and then after that, bila dah tamat, dah habis execute, so what happen? Dia akan repeat to step number. Okay, so this is the this is the summary of this one here. Okay, this description here kat sini. So mula-mula fetch instruction pointed by PC, dia akan ambil dulu instruction yang ditunjuk oleh program counter, and then program counter increment by 1 to point to the next instruction, then baru dia decode instruction, and after the decode dia akan execute. Once the execute is finished, then dia akan fetch lagi sekali instruction pointed pada PC, PC increase by 1, and then dia akan execute that instruction. Okay, so I will show you how the fetch and execute works. Okay, sekejap saya akan ambil. Okay, saya akan buka AVR Studio. Okay, saya nak tunjukkan macam mana fetch and execute berfungsi. Okay, for those who just join in, okay, pada yang mana-mana yang baru join, okay, kamu boleh scan this QR code ataupun okay, click the link that I provided in the chat box for today attendance untuk kedatangan hari ini. Okay, so this is the AVR Studio. So saya akan pakai AVR Studio 6. Okay, so I use the AVR Studio 6, tak pakai AVR Studio 7. So saya recommend kamu supaya pakai AVR Studio 6. Okay, so what we're going to do is, okay, so mula-mula, okay, so this is the what we call it, the AVR Studio punya interface. Okay, so you go to File. Okay, you're going to create a new project lah. Okay, so we create a new project. Okay, dekat sini, okay, you can see that sama ada kamu nak tulis dalam bentuk assembly language ataupun C programming. Okay, you can either choose to program to write a program in C programming or assembly language. So in this example here, we're going to do the assembly first lah. Okay, kita nak pakai assembly language and then next later baru kita pakai C programming. Okay, so I put the name. Okay, you can put any names here. Okay, so crash.
Record tak?
Yes. Apa dia?
Record tak? Yang ni
Yes,
Dr. record.
Ya, saya ada record. Nanti saya akan upload record ni dekat YouTube saya ya. YouTube channel, nanti kamu bolehlah subscribe my YouTube channel. Okay, so I put the name of this assembly language. Okay, any names that you're going to use. Okay, tak kisah apa-apa. Okay, you just click OK. Okay, so sekarang ni, okay, now we're going to select our device lah. Okay, kita nak pakai chip apa yang kita nak pakai. So, in this course, okay, untuk kelas yang ni kita akan pakai ATmega 32. Okay, you just simply write ATmega 32 and hit enter. Tekan enter. So, kamu akan nampak ni. Nampak ni, ada banyak jenis IC kat sini. ATmega 32, ATmega 324A, 324P, all those things. Okay, so we just click the ATmega 32. Okay, di mana ATmega 32 ni, nampak ni dia punya program memory is 32 kilobyte, data memory is 2 kilobyte, and EEPROM memory is 1 kilobyte. Okay, we just simply select this one here, this chip here. Okay, now kat sinilah tempat yang kita nak tulis. Okay, kita nak tulis kita punya program dekat sini. Okay, so contohlah saya bagi a few program kat sini. .org, sorry, org x10. Okay, and then LDI 16 0x 0 P 07. Okay, and then load I R70 X. Oh, yang ni saya pakai 10 saja. ADD R16 and R17. And then NO. Swap R17. No. Okay, so this is the program. Okay, instruction that I already write. So apa yang operation yang dibuat ialah, okay, first mula-mula yang ni first kat sini, okay, the first line here kita nak startkan kita punya origin di mana kita nak simpan. Okay, so this one here we going to simpan our program dekat alamat. Simpan program di alamat 10. Okay, OX ni maksudnya OX dekat sini, this 0x, okay, maksud ia ialah dalam bentuk hex. Okay, this number is represent dalam bentuk hexadecimal. Okay, every time you see the 0x, maksudnya you know that is belong to hexadecimal number. Okay, and then this one, load IR16 or 0x07. So what I'm going to do here is, saya nak masukkan value hexadecimal 7 ke dalam register 16. So at the end nanti, dekat saya punya R16 akan ada value 07. Okay, and then this one also samalah, load IR1710. But this one here, okay, kalau kamu tengok sini, saya nak simpan value yang ni ke dalam R17. Tapi apa yang beza antara value yang ni dengan value yang atas ni? Can somebody point it to me? Apa yang beza?
Dalam bentuk hexagon.
Okay, nampak ni. Yang ni tak ada apa-apa simbol kat depan. Betul tak?
Betul.
So this number here is represent by decimal number. Okay, so dia akan simpan dalam decimal number. So this is a 10 lah dalam decimal number. Kalau tukar dalam hexadecimal, 10 ialah, siapa boleh tolong saya? Apakah value dalam hexadecimal untuk 10? Kosong berapa? Okay, decimal 10, tukar hexadecimal.
0A.
Okay, 0A. Okay, you can simply press the calculator. Okay, so this one untuk apa ni, kita punya course yang ni, okay, you are allowed to use calculator. Okay, tak sama dengan kamu punya digital electronic tak boleh guna calculator kan. So this one you can use the calculator to convert to do the number conversion. Okay, and then untuk yang ni, ADD R16 R17. Apa yang dia buat ADD R16 R17? Okay, so this one here, apa nak dia nak buat ADD? Apa ADD? ADD is stand for addition. Okay, kita nak add value daripada R16 tambah value daripada R17, and we going to put the result to R16. So R16 sama dengan, okay, jangan panik. Nanti kita akan go through all this instruction here in the next module. Okay, kita ada banyak instruction yang kita kena go through nanti. Okay, so this is the one of the instruction, example of the instruction lah. Okay, so apa yang berlaku? R16 sama dengan R16 tambah dengan R17. Okay, so dia akan dapat 07. Okay, yang ni adalah hexa ya. Selalunya kita akan simpan dalam hexa. 07 tambah 0A. Okey, by right kamu akan dapat berapa ni? Boleh tekan kalkulator tak? 07 tambah 0A, sepatutnya kamu akan dapat berapa value dia? Okey, 17. 10 tambah dengan 7 tadi kamu dapat 17. 17, what is 17? 16 is FF 10. That is satu berapa? Boleh tekan tak kalkulator? Tekan je hexadecimal 07 tambah dengan 0A, sepatutnya by right kamu kena dapat 12. Betul tak 12? Okay, then yang ni swap R17. So what the swap do? Okay, sepatutnya swap ni dia nak tukar position. Okay, value daripada R17. Since R17 kita ialah 0A, so dia akan tukar A pergi ke tempat 0, 0 pergi ke tempat A. So automatically R17, after you execute this instruction, R17 kamu akan dapat A0. A0. And NOP is stand for no operation lah. Okay, so I just simply build solution, nak tengok sama ada kita punya, try to compile sama ada error ataupun tak. Kalau ada error, kamu kena troubleshoot lah. Okay, you need to do a debugging and find out what the error is. Okay, and then do the correction lah to the errors. Okay, so since this is a bit succeeded, okay, so no fail or skip. Okay, so now what I'm going to do is, so sekarang kita nak, okay, so kita nak buat debugging and kita nak tengok line by line apa yang berlaku. Okay, so this one I just select it into simulator. Okay, saya try lagi sekali. Start debugger and break. Sorry. Okay, so this is what happened. Okay, kalau kamu tengok kat sini. Okay, so this is kita punya program. Okay, and then this is your program memory. Okay, so saya nak tunjuk pada kamu, actually, Microsoft. Okay, so for the Atmega 32, okay, kamu akan ada 3 memory yang kamu kena ingat. Okay, satu ialah kita panggil dia sebagai flash memory. Okay, ataupun sometimes we call it as a program memory. Okay, then we have a data memory. Okay, and then the last memory kita kena tahu is EEPROM memory. EEPROM. Okay, so flash or program memory ni, okay, used to store all the program. Segala program-program yang kita tulis akan disimpan dalam program memory. Okay, contohlah kalau tadi kita tulis LDI R716 okay, 07, okay, dia akan simpan dekat dalam ini. Okay, dalam kita punya flash atau program memory. For the data memory, okay, kita boleh bahagikan dia kepada 3 bahagian. Satu, kita panggil dia sebagai General Purpose Register, I/O dengan RAM. Okay, so later we will in the next module, kita akan belajar more detail on this part lah. Okay, so what happened here, after you execute, okay, after you take this instruction here, okay, CPU ambil instruction ini, okay, fetch this instruction, CPU fetch instruction, and then after that you execute, okay, whatever value from this execution will be stored to the data memory, akan disimpan dalam data memory. Whatever value, okay, there are yang dihasilkan daripada instruction di sini akan disimpan dalam data memory. While for the EEPROM, okay, so tak perlu tengok pun tak apa sebab kita fokus only on this 2 memory. Okay, satu flash program and satu lagi data memory. So this is what happened lah dekat kat sini. Okay, so actually this one here, okay, so this is your program memory actually. Okay, kenapa kamu tengok kat sini, nampak ni, instruction yang kita tulis tadi disimpan dekat sini. Okay, in which, okay, the starting address of this instruction is started dekat address 10. Kenapa 10? Sebab kat sini tadi kita dah bagi tahu dia, okay, kita nak simpan program yang kita tulis ni dekat address bermula daripada 10. So that's why you see here, okay, dekat address 10, the first instruction load I R16OX07 disimpan. Follow by LDI R1710 di mana dia is in dekat address 11 lah. Dia is dekat address 12, 13 and 14. Okay, contoh kalau saya tukar ini, instead of 10 kita tukar jadi 03. Okay, so bila kamu run dia, Okay, so what happened here? Nampak ni. Sekarang, our instruction here, dia punya location dah bertukar. Tadi dekat 10. Okay, tadi kat sini. Dekat sini. Now kita dah store program tadi dekat address bermula daripada 03 sebab kita ada kita punya origin ni tadi. Okay, di mana kita going, okay, we tell the CPU, okay, simpan this one inside our program memory started at address, this address. Okay, so this is the program yang kita tulis, and this program here is disimpan dekat address 03, 04, 05, 06 and 07. Okay, up until here, ada soalan tak? Okay, that one is a program memory. Okay, now we're going to see inside our data memory. Okay, so data memory, okay, kamu boleh tengok dekat sini. Okay, kamu ada program counter, ingat lagi tak tadi? Step apa yang berlaku bila kita do the fetch and execution? The program counter akan ambil memory address of the next instruction, and one dah ambil, and that is the CPU will execute that instruction, and the program counter will increment to by 1 to point to the next address of that instruction. Okay, so at the beginning here, the program counter value semua kosong lah. Ini kita baru nak start ni. So all the value here is kosong. Okay, this is a stack pointer, pointer register, X, Y, and Z, status register. Later kamu akan belajar benda-benda ni. Okay, status register, and then you have the R0 sampai R31. Okay, so this R0 sampai R31 actually is your general purpose register. Okay, this is your register. Okay, dalam CPU tadi kita ada 3 benda penting kan. Satu is ALU, Arithmetic Logic Unit. Then you have the control unit and you have a register. So this is the register. Okay, the temporary storage data. Okay, from R0 sampai R31. And then we have a RAM. Okay, so this is the RAM lah. Okay, so what happened here is, okay, kalau kamu tengok ni, okay, the yellow lines here means that this is the program counter. Okay, so program counter sekarang ni tengah fetch instruction, this instruction. Okay, di mana this instruction is coming from address 003. Macam mana dia tahu this instruction nak kena ambil daripada 003? Sebab daripada program memory tadi. Sebab instruction load R1607 disimpan dekat alamat 03 dalam program memory. So that's why the program counter kata, okay, so in order to do the fetch and execute, we need to fetch this instruction ya dekat alamat 03, tapi dia tak execute lagi, dia baru fetch. Okay, so what happened? Bila dia fetch, okay, so the value masih lagi kosong. Okay, sepatutnya kalau kita tengok kat sini R16 sepatutnya 07, tapi R16 kita masih lagi kosong kat bawah ni. Okay, tak ada value lagi kat sini. Okay, because this is a fetch, fasa fetch. Okay, fasa baru nak ambil instruction. Okay, so what happened here is, bila once the program counter point to the next instruction, bila program counter, okay, point to the next instruction, dia akan point to this instruction, which is nak fetch next instruction. Okay, so sekarang ni program counter dah tunjukkan address 04, which is dia nak ambil, nak fetch the next instruction. So what happened here, barulah kita execute this line here. So barulah R16 ada 07. Kamu tengok R16 dah ada 07. Okay, and then the CPU. Okay, so this is the one complete fetch and execute. Okay, dia fetch, dia execute. Baru line yang ni. Okay, next kita kena buat execute the second line. Okay, so to execute the second line, the program counter must point to the next instruction. Okay, must fetch the next instruction. Okay, so sekarang ni, okay, nampak ni program counter dah increase jadi 05. So what happen here? Kita tengah execute this instruction. Okay, kalau kamu tengok kat sini R17 sekarang ni ada value 08. Okay, and then fetch lagi, baru kita execute yang ni ADD R16 R17, di mana ADD R16 R17 is 11. Okay, saya salah tadi. Okay, it's supposed to be 11. Okay, 07 tambah 0A, okay, you will get 11. Okay, so value ni tadi akan disimpan dalam R16. So that's why R16 masih satu-satu. What happened to R17? R17 value dia masih 0A, tak berubah. Okay, and then kita fetch lagi instruction. Okay, we're going to fetch instruction. Okay, because we're going to execute this lines here, swap R17. So what happened is, okay, so bila fetch next instruction, which is instruction dekat alamat 007. Okay, kalau kamu tengok NOP, alamat 007 is belong to NOP lah kat sini. So what happened? Kita tengah execute this line, swap R17. So kamu tengok R17 sekarang, dia punya value dah berubah. Tadi 0A, sekarang jadi A0. This is how the fetch and execute cycle works. Okay, fetch and execute cycle works. Any question? Ada soalan tak? Okay, if no question, I think we stop here. Okay, kita akan continue back at 2 PM. Okay, so kita dah finish our module 1. Okay, next kita nak masuk module 2. Okay, ada soalan tak? Before we stop and take a break.